Hi, my name is Michael Moreno. I am working with Chris Farnetti, Jason Hurst, and Wesley Donahoe on this project. We are designing these goggles to aid skiers and snowboarders in obtaining better performance while they're out on the slopes. This will also increase the safety factor by helping to avoid avalanches by displaying an active angle of the slope on the goggles. Our target customers are of course skiers and snowboarders. We hope to bring value to our customers by providing real-time data for them to interpret while they are skiing/snowboarding. This will allow them to become better at skiing or snowboarding by knowing how to react to different angles and different temperatures during their runs. Seen here are some pictures of our prototype. We used a pair of Smith goggles and we attached them to a Arduino board to make them display all that information. There's also a video of these working. The link is in the description. In order to make our design useful, we had to install various sensors to receive various data. We installed a temperature sensor to record the temperature, an accelerometer to record the angle, and a breakout board so it would have a continuous clock on it. One of the most interesting things we looked into when building this product was how to make it so that the users weren't interfered with when they were skiing. We didn't want a big OLED screen in their way. And what we came to a conclusion with is we could install a mirror that would mirror the OLED screen onto the goggles and provide a transparent display for the user. For production purposes, a screen as seen here would be more preferable to what we have now. We are using a mirror and an OLED screen, but it doesn't make the product very durable, and with the skier or snowboarder it would be nice to have it more durable. But the transparent OLED is definitely necessary to keep the view from being obstructed. Part of developing this product was providing the user with various readouts. As part of these readouts we've included a clock, a stopwatch so you can measure how long your runs have been, and an angle so you can measure the steepness of the slope, which will affect how you will react in different situations and along with how safe the slope is to ride. Our goggles do have some standard performance specs. The temperature sensor installed within them cannot go below -40 degrees Celsius and still read, nor can it go above 125 degrees. The angle, the accelerometer which records angle, however, can read any angle necessary. In designing this product, we interviewed various skiers and snowboarders about which features they would like. The results were slope angle, speed, temperature, time, runtime, and GPS. However, when asked about price, customers said they would prefer to keep the price lower and not include all of the features. For this product, we conducted an internal Josh Kaufman quick test. This is done by answering 10 different questions on a scale of 1 to 10 that pertain to how the product will act in the market and how the competitors are. Ours scaled a 72, which is a yellow light, meaning the product is possible, but to proceed with caution. When we looked into our competitors, we found two major competitors, the Zeal 3 and the Liquid Image XCS. The Zeal 3 had a ton of features, however is priced at $550, which is much more than most people are willing to pay. The Liquid Image XCS only included a camera, however was priced at $250, which was our target price for ours. In designing our product, we had to connect to the 5 human drives. The first of these is to acquire. People will want to acquire our product because it is unique, and the price is low enough that it is similar to a pair of regular goggles. We also had to connect with the drive to bond. People will bond with our product because once they start using it, they will realize how they can use it to develop their skiing and snowboarding abilities. We also connected with the human drive to be safe. Our product inspires safety on the slopes by giving riders an insight to the angle of the slope they are skiing or snowboarding, helping to prevent avalanches. We also connected with the human drive to learn by providing users with data to help them increase their skiing and snowboarding skills. Lastly, we had to connect to the human drive to experience. Imagine skiing or snowboarding down the slopes and having real-time data about your run being displayed on your goggles, while not having it obstruct your view. That is an experience. For this product, we also developed a pro forma income statement. We predicted a sales revenue of $25,000, a total expenses of $18,650, and a net income of $6,350. This left us with a net profit margin of 25.4%. Our financial plan makes several assumptions. The first of these is assuming we will sell 100 units for approximately $250 a unit. It also assumes all advertising will be done at the stores and no internet or TV advertising due to the type of customers we will be providing products to. In compiling our financial data, we went to Zeal's website to find out approximately how many goggles they were selling. We did this by seeing how many they had in stock, which was 500, so we assumed we could sell probably about 100 in a year. We also went to a bank website and calculated the interest expense in our loan at 8.125%. Some of our team strengths on this project include organization and the way we organized our tasks out and broke them down, meetings, which we had a gracious amount of time for, and trust. We had an insane amount of trust in each other that we would get things done. Some of our improvements we could make was less arguing. We seemed to do a lot of arguing during our meetings, and we could probably remove some of that. Other improvements we could make as a team on this project was better collaboration. It was difficult on this project because 90% of the work was coding, and it's hard to have more than one person doing the coding. Team insights eventually we had task leaders. That was the person responsible for the task, which helped an insane amount. We also didn't procrastinate, which helped massively in getting the project done on time. During this project we had several team lessons learned. The first of these is keeping everyone up to date with task progress, which helps ensure that all tasks are being handled and nothing is being dropped. The best way to do this is via standing meeting, which was our second lesson learned. A standing meeting is a meeting where everyone's standing up so that everybody just gives the most critical information needed without over-explaining themselves.